Hello everyone, welcome, good evening, hope you're doing fine. We are back with a new live stream here on the Crosslink YouTube channel and on Twitch. And again, we're doing another little one about the Voron V0. We also have a little giveaway tonight for you, everyone who has been watching for the last couple of weeks on Twitch. You will have collected nozzles, which are our loyalty points. Hello. And you can spend those nozzles for the giveaway if you want to join the giveaway. And if you don't want to join the giveaway, you can keep them as long as you wish to enter any future giveaways. So any details about that is basically available on Twitch. If you hit ! giveaway, you will get all the details, how to join, how it works. I hope the stream works. So let's see. Twitch is doing its thing, I guess. We're starting in a minute or so, 1 minute. We're gonna kick it off with first few things about the Voron Zero, some progress, because you didn't see the final printer yet. So let's see. I see. Ad break on Twitch. Everyone on YouTube probably doesn't have an ad break. Let's see what Twitch is doing now. I have no idea, honestly. Interesting. So 10 seconds to go, and we're gonna kick it off. Great. I don't know what's happening on Twitch with the ads. We're gonna check it out. Maybe we're gonna check out what's going on with the ads. What is Switch doing? Let's see. Are we doing this here? What is happening? Okay. Blah. Okay, so I think something where I think there was ads turned on the channel. For some reason I turned it off. So let's see. We're back now, and we're gonna walk through the Voron V0 and in its current state as a first thing to do. So I want to show you the printer. Last time when we left off, we basically did the first print test. We printed a bunchy. The printer wasn't fully complete in, I would say there wasn't no panels on the printer. The top head was missing, but let's have a look at the final thing now. I'm gonna quickly walk you through this little guy here. So I think this is the best way to do it, as a little bit of a close-up here. So the final touches I did last week to this printer, I've added all these side panels. So basically that's just the acrylic panels. They are all held in place with these plastic pieces here. And we have the front door. Easily can be taken off, just lifting it off. Then we have the top head, which is also, how many? It's 8 aluminium extrusions and some panels. So nothing spectacular, but it was just like basically finishing the enclosure last week. so it also doesn't collect so much dust when it's in the studio and it's not being used. And yeah, I guess that was mostly it. The skirts are plastic pieces here at the bottom, which are basically just closing the gap between the bottom and the lower frame part. So these are all non-functional add-ons, I would say, so they don't change anything regarding the printer. The only difference is going to be if you print something that requires a heated or at least some stable temperature in the chamber, like ABS, then having this stuff mounted is going to be important. Otherwise, you could also run this printer without any of the panels on. Last but not least, I added the display. That was missing. That I think I posted it also on Insta. It's very easy to install because it's just another clipper device that you flash with also the same firmware as the main board. So you install clipper on this little screen here, and then you have one configuration file to include, and it's just simply working. So you can basically just go here and change the filament, for example, from this little menu, and control the temperature, start a print from existing files. You can also start and stop Octoprint if you have Octoprint controlling your printer. Basically everything that you have normally on a clipper screen. Honestly, I don't think that this printer really needs a touch screen. You could certainly add a touch screen here, but you don't have so much space. So I think the only touch screen that would realistically work, maybe, I don't have it here now, a 35 millimeter, the TFT 35. Now I've used the TFT 35 on my D100 and it was, I don't know, I wasn't super happy with the screen. It was not, first of all, the touch reactivity, so the sensitivity wasn't great, and it was also giving me some strange ghost touching and could not resolve it even when removing the screen from the case that was originally on the printer. So that was the reason why I detached it from the D100, and maybe gonna have to test it. Maybe it was about the Big Tree Tech Pi. Maybe it works better with the Raspberry Pi. So we're gonna figure that out maybe in the future. But for this little guy here, I think it is definitely enough to have this little turning knob as we are used to, and it gives you basically everything that you need to control the printer. Now there is a little button here on the screen and an LED, so RGB LED, which can show you the status. You also have an RGB LED here at the front of this Kirigami bed. And here you have an emergency button, so you can press this button to stop the print immediately. So that's great, because sometimes you will probably run into some issues, or the printer is running somewhere spaghetti code and you want to stop it immediately. So you can just push this button, and it's basically doing the same thing as if you would hit the emergency button from the printer menu. And yeah, that's all the things so far. Now on the back we also have the spool holder, and I was testing out some prints with the spool holder, and it works. I must say it works. Maybe this is the wrong way, but it also has some issues. For example, it is like not very, the spool isn't running very easily, so it also has quite some resistance when it needs to turn. So there's definitely some force required to turn this, and even though there is now a PTFE tube here, that makes it easier. Still, it is way too much resistant for my taste, I would say. That's why I use the external spool roller, and I found a couple of other versions that are also having that also use bearings. So there's definitely a way to improve this thing. The only thing that we need to do is probably remix this mount, because this is detachable. So if we want to store this printer in the shelf, we can basically just remove this and put it to the back, so it's out of the way. That is something that we probably have to remix into another spool holder that I found that has the roller bearings, and then we have I think then we have the thing that I actually want. the perfect combination of this spool holder that's basically just disappears, or it's very flat at the back of the printer, and we can then have that as a combination. One thing that I want to do tonight is really tuning. Essentially just want to do some tuning of the printer, filament tuning, and I also want to try out the ADXL 345. Now, if you know, there is a vibration compensation sensor that you can attach to all of the Clipper printers. This specific version, the LDO Picobellical tool head, there is a ADXL 345 sensor already in this tool head PCB. So the only thing that you need to do to make it work with the Raspberry Pi is connecting it to the Raspberry Pi using a little cable, and that cable and a little adapter that we just need to plug into the Raspberry Pi's GPIO pins comes with this printer. And then we connect this cable temporarily while we do the vibration tests. We connect it to the tool head, and once we're done, we disconnect it and we can store the cable somewhere. So probably want to do this as a first thing, or one of the first things that we want to test out for this printer. Okay, so I guess ads, I think the reason why we've seen ads on the channel is probably because Twitch has changed my status to affiliate, and I think by default they enabled the ads, so I disabled the ads. Just oversight from my end. What we now have is emotes, which I really like. We have new emotes. We can now create our custom emotes. A couple of the first emotes that I've created for the channel are, try to come up with some emotes. One of them is the hammer. So that's definitely something we need. So we have a hammer emote now. So in others, you can figure out by hitting :Daniel, and then you will see currently the available emotes, and I'm gonna add more over time as soon as we figure out emotes that we want on the channel. I know, Alexander, the PTFE is probably a little bit too long, but still the amount of tension that the spool has on this external mount, I don't like that too much. It's really squeaking, so it makes some weird noise when the full. It might be also the cardboard spool that makes it is a little bit harder to turn. The plastic spools definitely were easier, and so from this perspective, probably it is not totally required to change that. But I think for cardboard spools, which are, in my opinion, the better spools for filament that you don't buy so often, or where you have like different colors and you don't want to have a refill system for that, I think you should go for cardboard because it's more sustainable, and the plastic spools are just garbage in the end. And the cardboard spools can at least be easier recycled, or you can basically just put them in the paper trash. And honestly, my plastic trash bin is every single time it's so full now that I actually prefer to have cardboard spools for stuff that is not where I don't need to refill, or where I don't want to have something big printed where I need 10 spools or something. Great. The bearing spool holder is definitely something. I found a couple variations. Didn't find one that is removable, at least not easily detachable, but I think that's an easy remix and should be doable in a couple of minutes to remix two different. Okay. Then, what is the giveaway for tonight? We are also want to clarify what we're giving away. Again, I think you've seen it already. I have this printer here, this way. Took it out of the box recently to see if everything is complete, if everything is in the box. hasn't been used yet, so it's a completely fresh printer, completely unused. The FlashForge Creator Pro 2 dual head IDEX printer, so you can't see this here because there's so much foam here. But it has two print heads, and they can independently print either two different things, or they can print the same thing twice, or they can also print dual colors, so you can put one color in one tool head basically and have a second color in the second tool head, and so you could theoretically print something that is dual color or something with support material in a single color. And yeah, it also comes with 2 spools of filament and everything that you need to get started if you don't have a printer yet. I think this is totally a great starting printer because it can do a couple of things. It's quite compact, and yeah, its versatility is great. So, and has an enclosure, so can also print materials that require an enclosure. That's what we're giving away tonight. You've seen how it works. I'm gonna do the drawing of the winner later on. Now I want to basically come to my Voron V0 tests. So, and I want to do a couple of things with Orca Slicer this time. So let's see what we can do from Orca Slicer. So the first thing that I realized, Orca Slicer doesn't have a profile yet for the V0.2, but I started creating my own printer profiles. So that's why you probably want to, yeah, if you're interested, I'm gonna upload them as soon as I can. I'm gonna upload these profiles so we can use them basically. If you have a Voron 0.2 and you're interested using Orca Slicer, this is probably the profiles that you might want to be interested in. So I'm going to put them on my website as soon as we have them ready. So one of the things that I want to do is calibration prints. Orca Slicer is pretty easy in this way. You can start, for example, you can calibrate temperature for your given material. You can flow rate calibration, pressure advance tests, retraction tests, tolerance tests, max flow rate tests, all that stuff. And there's a good tutorial. Then Bamboo Slicer has something similar. They have also some guides, but very much, I think it's harder to reach, and they don't have all of these calibrations there yet. I think there is couple of like 2-3 calibration tests that you can do from Bamboo Slicer. Prusa Slicer, I think I don't understand why it does have to be that difficult from other slicer programs to do these calibrations. This is so far the easiest to start all of these, and they have a pre-configuration, so you just have to basically do here. You don't need to set up anything, but for pressure advance, for example, you can just say, what is this type of extruder? Is it direct drive, Bowden? What do you want? Which kind of pattern do you want? Where do you want to start? And the steps. So it's quite easy. And so this works for all of these different tests. Now, we want to do some flow rate testing first, I guess, or yeah, pressure advance. I think I did this for the material, and flow rate test is something that we can also do to figure out is the flow rate correctly set, or do we want to change it? And then we have pressure advance, we have max flow rate. That was the first test that I was actually really interested to do tonight, because the flow rate of the printer is, from my perspective, could be better. And one of the reasons that I was curious about the flow rate is because of this filament spool holder problem. I wasn't sure if we're getting the same, if we got the same or the best results, because the filament was really, there was lots of resistance when the filament was pulling, or when the extruder was pulling on the filament. So I want to figure out if this had any influence on my results. So that's why I'm going to repeat this test for now. I'm going to start with 15 cubic millimeters per second. I'm going to end it at something about 30, and we see if we can actually push the limits with this, if we are like when we are reaching the limits of this specific combination. On the printer we currently have a 0.4 millimeter nozzle, the E3D and E3D Revo, and it's not the, I would say the nozzle is pretty standard, so it probably doesn't give you a crazy flow rate, but it is definitely exchangeable with a high flow rate version. So I don't have that here yet, but we can figure out what the standard nozzle that comes with this printer of probably any default 0.4 millimeter nozzle on this V0.2 direct drive will give you. The material is ESUN EPLA high flow, so it's a specifically designed material for high flow rates, and we'll see what comes out of this test, if we can actually reach anything beyond 20 or something. I'm curious, and we'll just kick it off right now. We're also gonna set the temperatures because I think the temperatures should be higher. Going for 220, 230, and the recommended temperature for this material is what? Yeah, 230. So I guess we're good. We should be going with the 230 for the test and take that as the input values for the first run. I also figured last time we had some Wi-Fi connectivity problems. That was actually due to a configuration problem on the Raspberry Pi 3. And that seems to be an old problem that came back with a recent software. And it can be fixed by adding some config file entry, and then now it's not going into power saving mode. So essentially the Wi-Fi was going into power saving mode, and at that point it disconnected and you couldn't reach it anymore. So that makes sense if you have a computer where you have like where you're actually in front and you're using mouse and keyboard. But for a printer that's connected to the Wi-Fi, and the only way to connect to it is Wi-Fi, and it goes to sleep, or the Wi-Fi goes to sleep, you have no way to wake it up because you have no keyboard and something that you can actually use to reconnect. So that's why I turned it off. Let's go with this. Let's see if this works. So we're sending this to the printer. So let's see. Probably want to open the door because we are printing PLA and nothing else. That requires the closed door. So let's see if we can monitor this like this. I am mainly curious about when this is going to fail. The purpose of this test is to figure out when the extruder is not capable of pushing more filament. So it's gonna start at 15 cubic millimeters and at 30 cubic millimeters. And you will see, at some point you're gonna see what you could call under extrusion, and also the extruder might start clicking, and that means it is going to, it's reaching the limits and it cannot push more filament. The only way to overcome that is by using high flow PLA, or which you are already using, so we already should have a higher flow rate, and using a high flow nozzle, which we do not have here yet. So we're gonna go with standard nozzle tests. Great. Is anyone else getting a delay between video and audio? I hope not. So far on my end, we have zero indication for that at least. Let me know if the stream has any issues. I hope we are good. Last time we had issues around midnight, so I hope this is also gone, because I moved all of the overnight upload jobs, backup jobs, moved them to 2 o'clock, so chat doesn't auto scroll. Well, that's something that I can't see or I can't control here. Honestly, maybe your Twitch window is fooling you. Okay, so what I hear is extruder is heating up. Should start any second with the homing. There, I think also some things that I fixed last week was homing on some of the scripts that were provided by LDO for the printer. So the homing script wasn't quite what I wanted, because homing should be done in a specific order, as crazy as it sounds. But if you don't do it in a specific order, your toolhead will try to home the Y axis when the toolhead is in one of the corners, and that's not good. So homing should always be done with the toolhead in the middle of the gantry and stuff like that. So these kind of little fixes. But so far, it seems to be very well calibrated in terms of the Z offset and bed leveling and stuff that we did already last time. Yo, okay. Hendrik didn't welcome everyone yet, but I see we have around about 8 people on Twitch and 7 on YouTube. Shout out to everyone who's watching. To them, Carmen, could have been you. G-Forces, Cylon, who's else there? Voron is there. Mujahed Kuya. Did I miss Alexander is there? Alexander, let's see if you're gonna win the printer. I hope not. Honestly, I hope that someone else is winning, but you never know, right? Eric's Coder, welcome to the stream. Valeri, hey. There's a couple of lurkers there that aren't saying anything, but let's see. My only concern with this print here is that we are in the middle of, or that we are not going over the corners. Actually, I got a little bit of a challenge to center the prints. Normally that's not that complicated, but here what a little issue is that, first of all, this print surface, this magnetic surface, there is basically no alignment helpers in any of the corners, so you have to put it in the same position every single time. But you can also slightly misalign it by 1 millimeter to the left or to the right or to the back or to the front. And so it is not always going to be the same exact position. Maybe there is a printable solution for this, so we have a little bit of alignment, so we can then calibrate really the 0, position correctly and also the exact available print volume. So I reduced the print volume by 2 millimeters just to be a little bit safer in that regard. So last time I did some tests, I ran over the surface by maybe 1 layer or something, and it was like always scratching. So I think it's crucial that there is something that's gonna make it consistent. But yeah, that's probably something. These are the fine-tuning things. Let's figure out how well this is working now. Maybe wanna Yeah, I think the tensioning screw is fine. And we should see in a couple of seconds that we're starting the calibration print. This first couple of loops are just for better adhesion, so we're not detaching. Let's see. How are you guys doing? I hope you're having a great evening, or wherever you're watching from, whenever you're watching from. For us here in Germany, it is 9:30 in the evening, but I know that a couple of you are watching from the UK, which is a little earlier, and also from the US, where it is somewhere around noon or maybe in the afternoon. So why this is running, I can tell you, I've been cleaning up the workshop. I have been doing some prints here that I wanted to put on my tool wall. Still, my tool wall is still pretty empty, so I wanted to have all of my daily use tools here. I started to print stuff that I want. For example, I had all my here my spray can. Just probably barely see this. We're gonna see this later. My compressed air, my isopropanol, Red Bull holder, stuff like that. That's already done, but I still need to do more tool holders and stuff that I want to have here for easy, quick access. Alexander on the balcony, nice warm evening. Okay, nice, nice. I think in Germany it's still getting quite cold. Actually, we had a crazy thing going on tonight. We had beehive. Or a bee swarm coming to the garden and settling down on a tree. So I've never seen that, but it's. I need a benchy holder, yeah. So we had this bee swarm that was probably swarming out from an existing beehive coming to the garden, and it was like a huge fog of bees all over the place, and we were like kind of worried where they would be going, and then they settled in one of the bigger trees, and now I think they're probably gonna stay there overnight. And we already called the beekeeper beekeeper club. Actually, we have a beekeeper just across the street, but he's on vacation. So I hope that they will take the bees and put them in a new beehive, because what normally happens is the bees start swarming when they are basically parting the beehive into two bigger chunks with the new queen and the old queen, and that means that you need a new beehive for the new swarm. So let's see what happens here. I hear already some noises from the extruder, and we're actually not that far into the test, which is unfortunate. Maybe we can tension. The question is, does more tension here help? If not, we can try maybe increasing the temperature. Let's increase the temperature by 10 degrees. If that doesn't help, we're probably. I've told you this extruder is not, or the nozzle isn't the fastest, so to say. It doesn't have the highest flow rate. That's at least my take. I'm increasing the temperature to 235. But I think it's not gonna help us so much. So yeah, I think we're already somewhere at the limit. So I guess what I wanted, I mean, this is not I wouldn't say this is bad or something. This is just gonna prove the limits. So we can already stop, I guess. So how this works? Combat Doggo, hey, welcome to Twitch. Thanks for following. Normally how this works is pretty easy. What you do is measuring out how is the where's the layer, or at which height do you see the first signals of under extrusion, and this is pretty much here. Yes, when we had something around 5 millimeters. So 5 millimeters, above 5 millimeters, we already see a tiny bit of under extrusion here. And you will, like, this is very visible, so easy to do this. The way how it works now is we're gonna take the 5 millimeters and we'll put them into this formula. So gonna go into Orca Slicer, and you could just check the, how it's calculated. So every single millimeter you have a 0.5 millimeter cubic millimeter per second increase. Now we started from 15, which was the lowest, and so that means we have essentially 5 millimeters times 0.5, which is 2.5, plus 15, which gives us 17.5 cubic millimeters per second as a safe limit. We could probably go a little bit higher and still get good results, increase the temperature, but yeah. So speed setting, because you're asking, speed has nothing to do with, like, it's connected, but speed setting and flow rate setting, you should look at it differently, because you should separate that. The flow rate is how much filament can be pushed through the nozzle at a certain temperature of a specific material, right? So it depends on the material type, the brand, and the temperature, and your setup, and how fast you're printing, like millimeters per second print speed, how fast the tool head is moving from A to B, does not necessarily have anything to do with the flow rate limit, okay? So the flow rate is really how much filament can really come out of the nozzle. It doesn't help you if you push the nozzle with 500 millimeters per second, but it cannot keep up extruding at that speed. So what you need to check first is flow rate. We can figure out how much speed you have at a certain flow rate, but honestly, that has also to do with, like, the extrusion ratio. If you have something that is infill, for example, and you're lowering your infill flow rate to print faster infill, so you can push your printing speed higher, extrude less, and still get good enough infill. For the outer areas, like the external lines that you're, like the external layer, you might want to reduce or set the flow rate to the best quality, reduce the print speed to the limit basically, and then you can, like, basically still print at limit, but that can't be any kind of speed for, like, the given printer. So we can figure that out now. But the thing is important is to know what is the maximum flow rate setting. Now what the extruder, what the slicer software will now do, we're going to take the 17.5 and going to create a new project. We're going to go into the filament settings, and we're going to enter the max volumetric speed as 17.5, right? 17.5 millimeter per second. That's what we are going to set for this specific filament and this specific, like, type of filament from this specific brand. And we can do the same test with equality filament, and we'll probably get a different number, right? Okay, so what we're going to do now to see how fast are we actually printing with this flow rate limit, in millimeter per second, we can now start a simple cube test and say, okay, let's print a cube or print something, I don't know, a cylinder, for example. And we could increase that cylinder to, I don't know, let's give it a size of 10 centimeters, or it's maybe a little bit too big. Well, let's say 80. So this is our cylinder. Let's center this, and what we will do, we're gonna look for how's it called? Vase mode. Spiral vase, and so we're gonna enable spiral vase. Yes. So we're gonna print this in the spiral vase mode, which is, and then we're gonna see, we're gonna play around a little bit manually with the speed settings, so we can figure out what is this print speed that still gives us acceptable results, and what is like millimeter per second print speed at this given extrusion ratio. Same as with the other test, but the circular test is where I prefer to do the manual stuff, where I want to change the speed settings manually, because you can see it easier. Like it's not going in these weird S curves, so you can always see it from the front very easily. Okay, so let's do that. Let's print it. Print speed setting is somewhat outer wall 250 millimeters per second. And what the slicer will do, it will take the flow rate and calculate how much filament needs to be extruded for the speed. And if it finds out that 17.5 cubic millimeters is too much, or 250 millimeters per second is too much for this extrusion flow ratio, it's going to reduce the speed. So you can set this to any value. We can basically set this to 1000. Realistically, it's not going to change the outcome, right? If you change this to 1000 now, it will still limit the print speed to what is doable with the extrusion flow rate, right? The speed setting actually doesn't matter now anymore. You can set it to anything. It doesn't change the limit. The limit will always be limiting the print speed to what the extruder can actually do. So let's print this. Layer height 0.2. So basically might just default for anything. Stream elements, thing 20 minutes and no nozzles. Is this still the okay. Combat doggo. That's weird, honestly. It should give you nozzles. Precisely should give you every 10 minutes should give you 5 nozzles or something. That's the default. Okay, so it should work. For everyone else, can you check if it works for you? Because I'm curious if it works. If it doesn't work tonight, I hope it works for everyone. We can check out the leaderboard. At least we can see if people are earning nozzles. We can let's check out the I think it's leader board, something like that. Here we go. Check out the nozzles leaderboard here, and yeah, so you can basically go there to this website. You can see the current nozzles. I'm not entering, of course. I have given myself some artificial number, but you can see that people have some nozzles collected, and whether they enter this into the giveaway or not is their decision. But that's how it looks like on this website if you click on the link. Let's go and see what our printer is doing. I'm gonna remove this first. Don't need that anymore. And So let's see. Let's see what we get. And now we're gonna fine tune the speed and see whether we get what speed setting or what speed readout we get. How to check this is basically while the printer is running, you can go in Clipper, you can always see speed and flow rates here in this printer menu. You will see like, we're gonna monitor what's gonna be shown there in a second once this print starts. Okay, so we get some spiral ways print. Let's go. I also added this perch line in my script because I always saw that the first couple of millimeters of filament weren't really extruded, so I was it's printing the first layer, so it's gonna be filling the bottom at least. So what you can already see, what is this print speed now? For this default first layer print, what is the print speed? So the flow rate for this is round about 9.4 cubic millimeters, so 9.4. So we're not at the limit yet, but are like reasonable print speed, and we are around about 105 millimeters per second print speed of the nozzle for that specific flow rate, right? So pretty much, yeah, it's a little bit faster for first layer. Seems no one is getting any nozzles today, so I'm curious, like, why is this happening? Stream elements, what is going on? Is that a problem with stream elements tonight? Maybe we need to check if stream elements has any issues. Chatbot, is it working? Loyalty settings, loyalty is enabled. We're getting nozzles, amount, 5 nozzles every 10 minutes. I didn't change anything, and it seems that something is not working. Yeah, seems that from your end, if it's not working, it's interesting. Strange. I don't get any error messages, honestly. So maybe because my status changed. What I can do, I'm now an affiliate, so maybe that changed something. Maybe I have to reconnect. Maybe I've just enabled or disabled the loyalty settings. Loyalty enabled, loyalty disabled, loyalty enabled. Should I change this? Strange. Leaderboard. So maybe I had to disable it and re-enable it. I did that just right now. I cannot like completely disable the account or something. So that could be, maybe if that has to do with my status Twitch changing to affiliate. That could be. I have no other like thing that I can do actually. So good question. What can I do as settings here? Settings for the bot status. I can disable it and join the channel. At least the bot seems to be running. Disconnect. I don't know. It should be working. If it's not working, I need to figure out why. It's very strange. Okay. How does it work? Every 10 minutes, you are going to be receiving 5 nozzles. Five every 10 minutes. Should be working. There is a subscriber multiplier. I will just set this to 1x. Okay. It's working on Clipper, yeah. The printer is running on Clipper. Theoretically, you could run this printer also on Marlin firmware, but it's not recommended because it's not able to drive the printer as fast. Nowadays, honestly, I think every new printer is running Clipper. That's just how it is. It's just the nature of things that the new replaces the old, and Clipper is definitely something that's going to replace probably most of the printer's firmware in the upcoming years. So if you're still running Marlin firmware, you can consider, if you're fine what the printer does for you, you probably don't have to change anything. But if you say, okay, I want to have new features or I want to have more control, like this web interface. So what is happening here? Now I guess we're talking. So we are running and we see exactly what you are asking for. What is going on? We have some spaghetti. Okay, we're already pretty much too fast, I guess. Frisbee. Okay, we have spaghetti. Why did we get spaghetti? Good question. Have we been already too fast? It's possible. Probably you should start slower. We should probably start a little bit slower. And maybe remove the bottom, like only print 1 layer for the bottom and not 3, which is a waste of filament. Where's my scraper? Should definitely print a scraper. No, I think it's waste of filament if we go for more than 1 bottom layer. So let's go for 1 bottom layer and start a little bit slower. Because the flow rate, I mean, this is what can trick you a little bit. The flow rate test probably was good, but the circular pattern honestly is pushing it even harder, because the circular pattern or the tube print is not slowing down at any given point, right? With the S-curve pattern, you will have some moments where the nozzle slows down just a tiny bit, and that might give the filament a chance to catch up. But the circular print is definitely brutal, and it's going to, there's no, like, once it starts failing, it's gonna fail, right? There's no way to catch up for the extruder. So let's go for, let's start with, let's go with 200 millimeters something. And then let's see where we end up. And we're gonna reduce the layers to 1 bottom shell. And that's it. And doing the same print again. Should start faster now. Brin is not needed, I guess, because we have a full bottom. And normally I don't need a print for this print. Never did for any of the other printers where I use this. So I think it's just a waste of material. I would say if we want to just print the wall without any bottom, okay. But the bottom print is also a nice test because you can see like whether your first layer is great. And I think it was good. So we can, yeah, we can also, if we have to do it all over, we can also remove the first layer completely. Next build, we will have a pizza printer. Yeah. So let's figure out the limits of this filament. 17.5 was the result of the first test, but I'm curious if this is really true. Let's see. How long until we start? Should be almost there with the temperature. So let's kick it off. Yeah, any moment. Did it change for you? Tudum Carmen, when was your last time you checked the nozzles? It was... When did you do this? 120. Okay, so it didn't change for you yet. I don't know what's going on, right? What's going on with stream elements? I don't get it. Did you? It's strange. It's strange. So I think maybe it helped that I disabled loyalty and re-enabled the loyalty. And again, it might have to do with the fact that they changed my Twitch status and something. And let's see. Okay, good. Okay. It's working now. Okay, maybe that was it already. Maybe I had to disable it and re-enable and that was it. And that seems to have fixed it for you. Yes! We're earning some cash. No, virtual cash, I don't know. I wouldn't call it that way. It's virtual loyalty. Great. So let's figure out the limit here. I think to push this printer even further, to print faster, we probably need some high extrusion nozzle. So I think one of the next things that I purchase is E3D high flow rate nozzle to see if that helps and how much that actually helps. We can also try out Creality high flow PLA. I think Creality has a pretty amazing high flow PLA, works very well. And this is the eSun. I was basically just curious how that works, if that works better or worse. Let's see. There is also another hot side, which is interesting because what you probably have seen in the build there is for the Revo, and don't get me wrong, I mean, I totally get that Revo system isn't cheap, right? It's actually quite expensive. But why is this in German? Okay. So the system is quite expensive, of course. I totally get that. but I've used it a while now. I think it's definitely something that you want in the end if you want to have exchangeable nozzle system and you want to have it easy in a way that you can swap it out without any additional tools, and you can just swap it out. Have different brands are offering nozzles already, so it's definitely better than something that requires some additional tools and where you have to hot tighten everything that is also not required here. But yeah, it's probably quite expensive. But there's also a different heater coming with it. So if you want to swap it out and the high flow kit, not only the nozzle but really everything, then you might want to consider also the heater, which has 50% more power, probably heating up even faster. So let's see. How fast are we printing and are we getting any issues? I guess we're getting some issues, but let's take a look at the print speed. The print speed is now 200. And don't do this to me, please. The print speed is 200 millimeters per second, 14 millimeter flow rate. And if we look at the layers, it's not ideal. We can, if we go down to 90%, let's see if we go down to 180 millimeters, it gets better. Yeah, but that's very strange, right? If you have something like, now we have 12.6 cubic millimeters per second flow rate at 180. In the test we had somewhat like 17.5 and we had a good result. So that is the question, like where do we set our limits now to get the best result? I guess we're catching up again, so we're probably gonna go down to 70%. We're gonna get a couple of nice layers. Temperature is 230 degrees. Let's push it a bit higher. So increasing to 240. So we should now hopefully get a couple of good layers so we can push it again. So we don't have this, we need one complete good line where I can settle the next lines on. So I think we're getting this now. We should have, I think we should have this complete line now, which goes around one circle. Okay, so we now have a full circle of good extrusion. So we are at 240 degrees and we have 140 millimeters per second. We can push it now by, let's go to 80%. 160 millimeters per second. Okay. This 11.2 cubic millimeters. I guess this is still fine. And now I'm going to go to 90%, somewhat 85% of the original speed that we had. That's 170. That is around about 12 cubic millimeters. Here we got the flow rate. Maybe we can, hope you can see this. 170 and 12 cubic millimeters, and we can now push it to 90%. Let's see. Still fine. So a slight temperature increase, 10 degrees more. Yeah, 10 degrees more. We're gonna push it. Okay, let's go to 190. So we have 13.3 cubic millimeters, not 190 millimeters. think we're still doing good. We can push it a little more. So does it still work? Is it failing at some point? Okay, I think it's still looking good. Probably we did have, the temperature was a little bit too low maybe for the first start. So going to 105% of our original speed, which is now 210, right? 210 millimeters is the new speed, 14.7 cubic millimeters. So are we still doing good? I think we're getting the first signs of issues here. We're probably pretty much at the limit, and we're getting the first problem. So I guess if we go back to 200, let's go back to 200. Definitely getting some issues here. It's not looking clean anymore. I'm curious if we keep it at 200 now, how does it continue to look like? I'm gonna get a little bit closer. So I think we're back to normal, and we seem to get good circles. I think we're back to good. So 200, but still we have 10 degrees more temperature. That means we also need more cooling, and potentially for some areas of the print we would have to slow down. Okay, so that is 14 cubic. It's actually lower than I expected to be, honestly. But yeah, let's print it. Let's stop it printing. Okay, so we can set this to 14. So 17.5 was a little too optimistic then from this first test. And honestly, I mean, we can try to push stuff as much as we want, but the thing is, if we don't get output from the nozzle, it's worthless, because then the printer can just not print anymore, and it can push the print head as fast as it wants, but if nothing comes out of the nozzle anymore, yeah. However, I wanted to figure out, this is the eSun ePLA high flow. Let's do the same test with the Creality. I'm curious if this is any better. Unload filament. Let's take the Creality high flow PLA. We also have it in, yeah, we can use blue. Just a rest. Couple of windings left, so we can probably do a couple of tests with this. So the Creality, did you unload? Oh, it's still heating up, okay. So let's swap out the filament, and then we're trying the same thing with Creality's filament. See if this is any better. And then we can take a normal filament, and honestly, I was always doubting that there's actually any difference between these high flow PLAs and normal PLA. Honestly, I don't know if it's some real stuff really, is it really going to be so much different? Or is it just a marketing gag? I don't know what your experiences are with these high flow, specific high flow filaments, if they are really that much better for printing faster, or if it's, I don't know, if they just have higher temperature settings on the label and that's it, and it's basically the same filament. I didn't do any thorough testing yet on this to compare these filaments, but that's why. We're gonna figure this out. Whether this makes any huge difference for... Did you unload? Ah, okay, now it works. No idea why it didn't unload. Okay, so new filament comes here. Let's go. There we go. And load filament. Load filament. We should see it in a second. There we go. So, for the test, I will just do the same test again. Maybe we just want to save some filament, remove the bottom layer and have some rim. Okay, so this is going to save us some filament. Speed settings are same. We are going to copy this filament and create a new version that's called Creality Hyper PLA, whatever. Creality Hyper PLA. And what is officially on this is temperature should be same, 230 degrees. But there's no number about, there's no cubic extrusion rate limit on this spool, so I'm going to set it to something similar. Okay, so let's set the limits to, I don't know. Let's go with the same actually. Let's start at the same limit and work upwards. We can always push it by changing live settings. So let's take this as a starting point. Okay, so we're gonna start same here. And what are you doing? Why are you not doing this? Okay, let's kick it. So using the same settings, will the flow rate be higher if the nozzle size is greater? That is a very good question. It could be higher. However, the limit is not only determined by the nozzle diameter, but it's also by the heater. So that's why there's a different version of the Revo system. There is a high flow hot side. That's not only the nozzle different, it's also this heater element. The heater normally has, this one has 60 watt. And the normal Revo has, I think, 40 watt. So that's 50% more. Let's see, Revo Voron. It's a little bit easier to find. here we go. So there's different versions of this. So there's the starter edition, 24-volt starter. I guess that is what we actually got with the kit. This is the normal Revo hot end with the, I think in this case, 40-watt Revo heater core, a 0.4 millimeter nozzle, a 0.6 millimeter nozzle that comes in the kit. And so that is the starter kit that you get with the Voron Zero or any other Voron printer. And unless it says differently, unless it explicitly says that it is the high flow version. Now the high flow version is significantly more expensive, and it also has a better heater core. That is this part here where you screw in a nozzle, which is heating up the filament. And that has, in this case, it has, I think it's high flow X. Some version of that. Here we have to go down. The starter kit, the high flow, where is it? There's a high flow. Here, the high flow version, it has the 60 watt. And also has a specifically called Revo high flow nozzle. So two things are working together in this case. You could also like just use your default nozzle with a higher heater core, with a better heater core. Maybe that's gonna change something, I'm not sure. So let's see what we get. Currently printing at 50, and we're doing the brim. I've switched off the first layer completely, so we're only printing a brim, and then we're gonna start right into the vase mode print. And we are starting at 200 millimeters per second, if I'm not wrong. Hyper PLA. Creality. Let's see if you can do better. Okay, so we're jumping into 200 millimeter per second, roundabout. We have 14 millimeter flow rate, approximately. I think we're still doing okay. Let's see if this has already some issues. Maybe it has some issues. Well, to be fair, we want to push the temperature to 240. Okay, so we're going to push it. Increase to 240. So, as we did for the E3D, the eSun. So we now have 240. What is happening? Did I hit a button? What happened? Some error. What's the error? Heater did not heat at the expected rate. Nice. Okay, I think we kind of fooled it because we increased the temperature during a high flow rate print and it couldn't keep the temperature. Okay, so let's do it different. Let's start directly with 240 temperature. So let's go for 240 max, 240. Let's go for 240 and 230. Yeah, I think we should not have such a gap here. Creality, blah, blah, blah. I think the pressure advance is something we need to figure out if we need to adapt this later. Okay, so maybe this helps. Okay, let's see, we have to remove that garbage first. Can we? Okay, so that wasn't so successful yet. Whatever that caused, I have no idea. Come on. Okay, so let's give it another shot here. And oh, we should probably no, we did reset. Okay, is it printing? What's going on? Oh, it's already starting. Okay, good. Starting up. Creality Hyper PLA. I'm curious if this changes anything on the behavior. But I guess the hot end had some issues keeping up the temperature, and that was like, I think normally what happens if the heater isn't able to push the temperature higher in a certain amount of time, it will get an error. So it will think that it is not reading the right temperature values for the amount of energy it's pushing in. So it's like, why is it not going up? No, because you're printing too fast. Let's see. We should start any moment. And hopefully not stop again from some weird temperature problem. I think we should change that. The LED is not showing anything at the moment, it's dark. I think once we start heating up, it should be red or something. We should change that in the starting script. I'd prefer to have some indication of the heated bed being turned on. That's just a simple script that we can run. But let's see. Hyper! And let's go. As a printer used as a replicator in one episode. Nice, nice, nice. Could be. The future. At some point we're gonna print food, or for sure can already print steaks. Okay, so can we get this, please? Maybe we're gonna slow down first to start. Oh, I'm all in for starting at the higher speed. Curious. Okay, so it's going to 240 degrees now, and I'm curious, can it keep up the temperature? Is it going up? Okay, it's working at least. The temperature is going up slowly. Oh my goodness, it cannot raise the temperature. It has some issues. If you look at the screen here, you see that the temperature is, maybe we should slow it down. The temperature is not going up. It is stuck at 235 at this speed. Now if I reduce the speed, let's see if it can go up. So it is definitely, it has troubles to increase the temperature. That was the reason why we didn't get there. So probably pit tuning could be helpful. Now it has, I think it has a chance now. At a lower speed we can get it there. I will wait until it reaches the 240 and then we're gonna push the speed. But yeah, you see this is probably one of the points of the limits of this extrusion kit is not only the nozzle, but it's also this heater core. If 40 watt heating power is probably not enough, you see it's not really working. We could do a pit tuning, but if that helps, I don't know if that will help in any way. So, okay, yeah, maybe we go to 235 as you just suggested. Let's go to 235 and go with that. Xyleon, subscribed with Prime. Oh my goodness, thank you very much. You know, actually you're probably my first subscribers on Twitch. The first 10 subscribers actually will get some kind of special badge, which is like first. So if you start chatting now, you should get a special badge in your chat messages. I'm curious if that actually is true because I was just reading about that. Yes, you do. You see what I mean? You get this first. I like it so much. This is so much fun. Okay, so let's not distract too much on screen. But yeah, thank you for using your Prime benefits to subscribe and get your first badge. That's awesome. It helps me tremendously with this channel. So now let's get back to, let's see what we're getting. I think we're getting some issues. That is unfortunate. If I'm honestly, I was expecting more. I was expecting more from this filament. So the strange part is now, and I don't fully understand, we cannot push the temperature to 240, which we were able to do with the eSun. So how can it be that the eSun filament can be like? Is it heating up faster? Is it? I don't know. What's the difference? Now the eSun filament. Okay, we could do the test again with 235 for a fairness comparison, but still, the result now looks not great. If I'm honest. If we go now, thank you, Mima917 for following on Twitch. Thank you very much. If we go down a little bit, I think we're now out of trouble. We are good. We had some issues here on the side. Is it working now? I think we still have not the perfect result, but let's monitor this speed for a couple more rounds. It seems that we're good now. The thing is with the print speed, it's a little bit disappointing with the Creality Hyper PLA. We are at 167 millimeters per second with 11.7 cubic. That's not great, honestly. That's not too great. The temperature is now pretty much consistent at 235. If we push a little more now, if we go back to 175 millimeters, I'm curious if we get any issues. Let's see if we get more problems again. I'm not sure, honestly, if we... I think it's... We still have some issues here. It's not in the front actually, but it's here when probably when the layer change happens. This part is still fine, but here, over there, when we do the layer change, we have some trouble. So, but still, it is slower. It is definitely at a lower speed than the eSun high flow PLA. So definitely there is a difference, right? The eSun filament had less problems, was printing faster. So I would say the Creality filament is definitely not at the same level in terms of the print speed. Okay, so let's say we keep these values as they are at the moment and keep them as the upper limit, 176, but the flow rate is 12.3 or something, or let's say 12.5, which is reasonable then for this filament. So we're going back to the filament settings, filament 12.5. And don't get me wrong, you will have different results with different printers and different setups. It is not about this. This can be higher with other printers, definitely. It is not about the filament so much. It's the combination of the filament, the temperature, all of the stuff. So go lower. So, and also these temperature changes. I mean, if you have higher temperature, you will also need more cooling. So it's definitely the thing to consider. So the max volumetric flow rate will now determine our speed limit when extruding. It doesn't limit us from moving the print head faster when we're not printing, right? So if we're not extruding, we can push the print head much faster. We could probably push from A to B without extruding, or we can reduce the flow rate. I think that's definitely still good, but yeah, definitely I think the Creality PLA is a little bit slower in terms of it's extrudes slower and cannot be pushed that much. Can also be a topic that is different with Creality printers. Maybe it's better on a Creality K1 and it will get you different results. So let's unload this filament. Come on. Filament. And we will do something that we wanted to do last time. We will print a proper benchy with these new settings, and we'll see what we can get in terms of a benchy printed with a proper flow rate, with hopefully no extrusion problems. So I want to see a benchy that is not just recognizable, but really as you would expect it, right? With no visual terrible issues. The last one wasn't that great, honestly. The first couple of layers were kind of terrible. If you look at this, I mean, this is still recognizable. It's still fine in the upper sections, but only because I increased the temperature and I changed some settings. The lower part is, I mean, it's probably acceptable somewhat for a speed benchy, but if you ask me if you want to get this into, if you want to do some proper print with quality concerns, not the greatest. Then I printed this cube here with more conservative settings, slower print speed. That's still good, but we will have to do the resonance compensation test because we still have some ghosting going on, right? We have a little bit of ghosting here with this cube. So we definitely need to take care of this ghosting, and we need to do resonance testing as well. Great. Okay, so let's use the new filament. Why did it not unload the filament? I think I need to increase the length of the script. Yeah, I guess the unloading script needs a little more unloading length, so it pushes the rest out. And we're gonna use the eSun PLA again, because that's the best, at least what I think now is the best filament for printing faster. Okay, so let's load that in. That seems to be fine. Coming out any second. Where's my garbage here? Okay, let's go. Good. That's good. Okay, so with these settings, let's figure out. I think we have not changed anything else. We only changed the filament. We're going back to the eSun and we'll do a new project. Discard. We're going to print some benchy again. And this time, let's check the print time now with the limits that we have set. Okay, so the print time seems to be 34 minutes. So we have some tweaked settings for benchy rules. That is a different layer height, 0.25 millimeters, and some other changes, mainly regarding the line width. I think the line width is, the allowed line width is 0.5. We need 2 wall loops. We also need 10% infill, 3 bottom, 3 top shell layers, and I think acceleration values are also pushed quite far, to 10,000 millimeters. The question is now where can we push the speed a bit? Last time I realized we did we managed to print it in 60 minutes 23 seconds, and we would have to find now some settings to push it and find out where we are spending most of the time. Where are we spending a lot of time? Where could we optimize our print speed? Now, knowing that we have a certain extrusion limit, so the material will definitely limit us from extruding faster, and also the nozzle setup. We need to find some way to optimize this. So we could try to reduce the flow rate for infill, maybe a little bit. Yeah, is this actually possible here? I'm wondering if this is available as a setting. Can we probably look in the material settings? So we can flow ratio 0.98. We can go with a little bit of a higher temperature. Go a bit higher, not too much. Then, so we are cooling, but we don't want to limit. So we don't want to slow down for cooling. That's the compromise. Otherwise, we could, if we could, we would aim for the maximum quality. We would slow down for better cooling, and that would automatically fix the print speed according to layers, time, and stuff. Air filtration is not available here. Retraction, we don't care. We probably would want to set it again to 0. And I guess I'm wondering, is this everything that we need? We also probably want to disable any retraction, or any, not a retraction, but we want to disable Z-top. This is already disabled. So the question is, do we want to retract on layer change? Maybe that we're gonna save a couple of seconds. That could save us a couple of seconds. I don't know. Let's see what comes as a result. 18 minutes was still pretty much there where we have started. Anything else that we could remove? Any suggestions from your side? What could we do to push it? We could also, like, we could go for higher infill speed, but we could increase the material flow rate and just say we figured out we can print quality at 200, but we could compromise the infill. We could basically just push the first layer speed to maximum, which is okay. And then we could increase the flow rate to, I don't know, let's say 20 or something, and push and let the other print speeds like they are. Like, so we don't want to reduce the first layer speed, because we know 200 is actually the flow rate limit for quality for the first layer. We also know outer wall speed 600 is definitely not going to happen. We're going to see the limits for 200. We could say to outer wall, I don't know, 220 or something. Inner wall we could push higher. The infill 650. 650, top surface, I don't know, top surface 220. Gap infill 600, bridge 50%, 15 milliwatt, bridge 50. Maybe we just want to push the bridge speed to, I don't know, 200. Why 150, 250% of what? Moment, just a moment. This is the speed for bridges and 100% overhang walls. What I saw the last time, the print was slowing down significantly at some minor details, and I was wondering, why is it going so slow? Right? Why is it going at some, even not outside, but really internal features, it was slowing down. Could this be... I'm wondering what that could have been. Slow number of slow layers. No, we're not gonna print any other layers slow. Maybe we just wanna say bridges speed. I don't know. Let's go for 200 or something. Let's see if that changes a lot. 16 minutes. So probably want to push the volumetric and just risk some loss internal. 15 minutes. So what we could do is really reduce this, like limit the outer wall speed as much as we can. So we can like basically have the outer wall with the say proven temperature and speed. That works. The inner wall, I don't know if we want to go that high, maybe 250. And then we can, and anything else that's infill, we could just push it like crazy, just to ignore 45 degrees. Okay, turn the benchy 45 degrees. Good call out. Let's see if that changes. What does it change? 14 minutes. Okay, it's giving us a couple of seconds. Okay, so ideally we would be under 15 minutes. That would be actually a good first result. Don't we want to try that maybe? 15 minutes was also my limit for the V100 benchy. The V100 was, I wouldn't get a serial number if I was over 15 minutes. Now we have the serial number for the V100 and we successfully printed under 15 minutes. And that was also my goal for this printer. I wanted to get under 15 minutes. So if we do this now, we would have 14 minutes, 54 seconds. Let's see if this is... Acceleration. The question with the acceleration is, I already have it at 10,000. And I'm not sure what is actually in the printer. Let's see what we have in the machine settings. We have 10,000 in the machine settings. Max velocity is something we should push here. Let's say 700. We could push this higher, so we can actually set something higher, because this is going to be the ultimate limits. If I'm not wrong, it's not going to be possible to increase them more than this. So bridge acceleration is 75%. Let's say 100%. How much is this changing? A little bit, couple of seconds. Now it's still, I was wondering during, like we will see this probably in the video, like in the first couple of layers, especially in the bottom layers, I saw that it was significantly slowing down at some, I don't know what that was, honestly. Let's, small parameters. Maybe it's this, maybe it was this. I don't know if this is going to be a thing. Skipping at 25K. So that is the thing with this printer. I have no idea where the real limits are yet. We didn't push it beyond. We can try. We can try to let's start like this. Let's start with the 10,000 and let's keep it like that. We don't want to change too many things. I mean, we already changed so many things now that we want to maybe we want to give it a try now with these kind of settings and figure out if we can get a benchy out of there and stay under 15. If we can stay under 15, we can already be proud because we already saved 1 minute and 23 seconds somewhat. Let's go. Let's go with this, and I think we should monitor this now and see if it works. Maybe let's close the top, otherwise it's gonna be shaking so much. Then I am preparing, next I am preparing to draw the winner for our little giveaway. I think disable layer minimum time. Where could we do this? This was in the, where was it? Layer minimum time. Was it in the printer settings? Or was it in material? Was it in the material? Cooling? No. Where? Let's search. Let's simply search minimum wall generator, minimum wall width, wall length, feature size, wall generator, first layer, minimum wall width, overhangs, make overhangs printable. Is this maybe a setting that doesn't exist in Walker Slicer? I'm not sure. Is it layer minimum time? Do you mean is this the time for cooling? There is a setting that's called max. There's a layer time setting. The printing speed in exported G-code will be slowed down when the estimated layer time is shorter than this value in order to get better cooling for these layers. Can set this to 0. See if it makes any difference. Now in this case not, it doesn't make any difference because we already disabled slowing down for cooling, so I think it doesn't make that. That's why it doesn't make a difference anymore. So let's see, we're heating up. Still waiting for the hot end. Hot end is heating up now. Let me, in the meanwhile, we will get ready for our giveaway. Just gonna prepare the page. So in the meanwhile, because you're just not doing anything, you should go to the giveaway page. Basically, you don't have to go to the giveaway page. You just go to Twitch chat, say ticket max. Right, so you say exclamation mark, ticket, space, max, and get your tickets in so you can join the giveaway. If you want, right, if you don't want, if you say this printer isn't, I'm not interested in getting the FlashForge printer, but maybe wait for the next giveaway, that's also fine. I see currently we only have 3 people that entered the giveaway, which is crazy if that would stay the way how it is, because if you do that, we only have 3 people to enter into the giveaway. There's pretty high chance for everyone to win compared to anywhere else what you probably enter some kind of giveaway. Great, timer. Are we missing a timer? I'm basically just, let me bring up the, that's actually a great call out. Let's do the following because it's easier to do this. We have a timer, right? We have a real print timer from the printer. So why don't we use that? Why don't we use the print timer? Okay, so let us add window. Good question. Can we just add this? Orca. Slicer. Okay. Of course, slicer. Okay. Is it working? No. It's not working. Okay, so we are at, so far we have 6 minutes, 35 seconds so far. I'll tell you the time. 6 minutes, 35 seconds so far. And it's not really sharp. Why is it not sharp? Can you please focus here? It's better now? Porphyrius, I think you're mistyping the commands, right? It's ticket max. And not tickets. Okay, then don't enter if you're not entering, if you don't want to. Okay, so what about the print quality? I'm curious. I think it is a bit better than last time, but only slightly, honestly. It is not tremendously better. Somewhat better, but not much. I think we still have this, probably still have a slight cooling issue. Okay, but at some point, probably this week, I will just do this again and record a serial number application video. For the serial number application for Voron, what we need to do is we need to record this very benchy print or a benchy print. Luckily, there's no limits in terms of time, so you don't have to print it in under X minutes. And then you have to write your name and some details on a sheet of paper and film that together with the printer and then send it to the Voron team so you get the serial number. I think that's something I'm going to do separately. Tickets, that command needs alias too. Yeah, you're right. Let's do this. Let's do tickets max. I think we can figure out if that works. Tickets. Didn't I do this? Let me see if I can, if I already did this actually. Chat commands. I did Where's my ticket command? Here we go. Edit this command. Tickets should actually work. If you say tickets max, it should also work. I think I did this alias already for the entering the giveaway. You can try out tickets max, should also work. If not, I'm wondering because it's yeah, sure, yeah, it's that was already in place. The only thing that's if you just enter tickets, you will basically just get an instruction how it works. Okay, great. So Banshee printing as we expected. We have currently we are at where is it? Where's my? Come on, here we go. We are at 10 minutes 50 seconds, so I am not sure if we will make it under 15, but I think this includes also heat up, so we definitely need a timer for this. I think we're doing actually pretty fine. Quality-wise, I would say we get some similar result as last time. We get a little bit better bottom layers, slightly better. The first couple of layers are a little bit better, but still it seems to be improving in the upper layers since the heat creep from the print bed isn't that significant. The elephant foot is definitely less noticeable this time. It's definitely less curved. So from that perspective, I think it's actually a little bit better now. I still would slightly decrease the bed temperature, so we just get less temperature pushing into the print from the bottom. So 60 degrees, I think we can go for 55 and still be fine. So, I guess what we're doing now is we're going to finish this print. We're going to do the drawing of the giveaway, and then we'll do another one where we push a couple of the settings a little bit more. And we'll use a proper timer, so I have to find where's this other phone. Because I had this bigger phone here. Where is it actually? Let's use the different stand here for the phone. I guess this is good. Okay, then 5 people have entered the giveaway. Okay, not so many yet. Okay, guys, if you just want to enter with one ticket, you can of course do tickets. But if you want to enter a specific amount, you can just put, say, tickets and then a number, right? So it's not only one, but maybe a couple more. Up to you what you want. Completely up to you how many you enter. So let me check out chat protocol. Oh my goodness, Porphyrius, you also subscribed with Prime. Thank you very much. I completely missed that. Oh my goodness. That's the second subscription to the channel, which is amazing. Thank you very much. Just to say I participated. I see. That was me. Thank you. The thing is, we'll unveil the next giveaway for the next month as soon as we have finished this one. I have something exciting for you. Definitely. Thank you. Thanks for the sub. And I think it's something great. I'm just gonna get it ready so we can show it. Give me a second while we are printing. Problem is it's very much buried under the other packages. So let's get it up here so we can get it out. Here we go. I think this is the right pack. Yes. Okay. Okay, so how are we doing? How many minutes already into the print? 14 minutes. Why is it not loading? Don't tell me that you disconnected the Wi-Fi again. Little garbage truck. What's going on? Even though I did turn off the power saving mode of the Wi-Fi, it did still disconnect. Why? Disable retraction. Is this maybe something? Is this allowed? Is retraction a must-have for the Speedbenchy competition? I don't think so. Let me see. Let me see the rules. Let's check the rules. You must use PLA, not filled metallic silk, as these filaments typically hide defects. The maximum nozzle or line width is 0.5. Check. Maximal layer height is 0.25. Check. You may combine infill every other layer. Maybe that is also, we need to check that setting actually. Combine infill every other layer. So we maybe can save some time there. You must use 3 top and bottom, yes. You must use 2 walls and 10% infill, yes. The finished print must be dimensionally accurate within reasons, bonus points if it looks good, yeah. But the bonus points are not, we're looking for the speed, right? Yeah, Swapper Motors machine, you must record the whole print, you must post the video, okay, you must share the print profile. Okay, so what did we not set? I think this might be a good hint here. You may combine infill every other layer. Maybe we'll find a setting that can help us here. I think it is, was it here? We're finishing the print at the moment, but I'm not sure. I think we should retime that next one. We should push it a bit higher now. So print time 15 minutes 24 seconds. I think print 15:24. So 15:24 is definitely faster than last time. Definitely faster than last time. The question is, can we increase it a tiny bit with these, with a couple of other settings. So let me figure out, can we combine infill every other layers? Where can I find this setting? Detect overhang walls. This detects the overhang percentage relative to the line width and uses the difference print speed to print. For 100% overhang, bridging speed is used. But I think we set everything to the same speed anyways. Travel speed. We could increase the travel speed maybe. I don't know. But where is the setting of combine? I think it must be here with strengths. Top shell thickness, sparse infill. Here, automatically combine sparse infill of several layers to print together in order to reduce time. Walls are still printed with original layer height. So we are allowed to use this. Okay. That would be one thing. How much does it save us? Apparently nothing. See, at least there's no difference in the calculation. What if we reduce or if we disable retraction? Retraction. 0 retraction. How much does that change? 14 minutes, 7 seconds. So we can completely disable retraction and we'll save another minute. Okay, that sounds reasonable. That sounds reasonable. Okay, we'll do another one in a couple of minutes. Before that, we will draw our winner. So this is the official page. 7 people have already entered into the giveaway. 422 tickets have been bought. This is your last chance. This is how many tickets have been bought by people. Not showing the final number yet. It's actually overlaid by my face. So you can still get tickets for the giveaway. Flash Watch Creator Pro 2 3D printer giveaway. Last chance is now. Tickets max if you want to push in all of the tickets, if you want to throw in everything into the pot. Do it now. I'll give everyone everyone gets another 20 seconds to do this. And then I will close the giveaway and we'll see. Good luck, my friends, good luck. Aiming with the one nozzle for a Teilnehmerurkunde. Okay, Teilnehmerurkunde. Yeah, okay, great. Let's see. It could be. So, let's go. I think we're closing it now. Okay, close giveaway. No entries anymore. Chat tells you this. And we can draw a winner. Let me see. Okay, 3, 2, 1. Mr. Nicewise. And guess what? Guess what? You don't see it because my face is over this now, but Mr. Nicewise entered this giveaway with 5 tickets. With 5 tickets, and you get to win. That's crazy. That's crazy. But that proves that it's definitely luck. It's just luck. Wow, under 1% probability to win, and you got. And some other people had entered with 145 tickets, and you have won with entering 5 tickets into this pot. This is crazy. Honestly, that's crazy. But okay, so let's congratulate Mr. Nicewise. What I will do before I forget about this, I will send Mr. Nicewise a private message, and got it. And I'm gonna ask you for your email in the private message. Don't send it here in the public chat. Just answer my private message for following up on the shipping. So I'm gonna send this to you. Please answer my private message on Twitch, and we're gonna get in touch. With drawbacks. Alexander, yeah, you weren't lucky this time. But since we have clarified now the winner for this giveaway, congratulations, Mr. Nicewise, getting this awesome Flashforge dual color 3D printer. What is the next giveaway? Someone guessed it already. Mystery box. What could be inside in this box? It's a flat box. So just probably need to remove the shipping label. So in this box for May, actually, not for April. April giveaway is gone. For May, we have an Atom Stack A5 Pro laser engraver. That's in the box. You can take a look. Just need to should remove the label, my friends. Why is it? Actually, I don't know where the up. Where's up? Up is here. Okay, so we could take a look inside. Just as I think I had it already opened, just checking, but I can open it again because where's my knife? Here we go. Let's check it out one more time. Did I already open it? I'm not sure. I think yes. So that's what we get. That's the giveaway. In a fancy color, actually. That's kind of a purple color. Looks fancy. And it's actually quite big. If you what's the laser volume? I think it's probably 40 centimeters or 40 by 50 or something. Where is the tech specs for this device? Is there anything? You can look it up. I think it's something around 40-ish centimeters long. Oh, it's German manual, so here's the English one. Doesn't tell us about the length of the extrusions, but we can check, like we can just manually measure out. Where is my stuff here? So, what's the length? Somewhat 54 by 54, probably 54 by 54, or 400 by 400 or something. 400 by 400 is probably the realistic, usable, the usable working area. And the laser module. Can we see this? How much that is? Class 4. Nothing written. Nothing written on it. Probably 5 watt. Might be right. So for etching stuff, engraving, that's definitely powerful enough. And cutting some plywood or at least some thinner woods should be doable. So yeah, let's see who's gonna win this in May. I'm gonna announce all of the date and blah blah blah. I don't know. You can also swap out the module for something more powerful. I think the base and the foundation, if it's not powerful enough, it's good. But yeah, that's free stuff. I hope that you can still use it for something. When I ran my engravers with little power for doing stuff, and cutting is something that I never really tried, but let's see. It's probably fun. It's a fun tool. Okay, so Mr. Nicewise, I've got your email address. Thank you. I'm gonna send you a follow-up email tomorrow in the morning with all the infos and stuff. So we can exchange infos. And yeah, again, we have a couple of things going on this year. We only have so many more things that I want to give away, that there's something in for everyone. So let's do our next Benchy print, but this time proper timer. And let's push this back a bit so we can hopefully see the timer. Otherwise it's not going to be possible. What about the quality? Let's take a look. Actually, it was not too bad. Let me see. Spot focus is on. Yeah, it's definitely a little bit better than last time, but still we have these temperature problems in the lower areas. The elephant foot isn't that prominent this time, but still you see the temperature from below, from the heat bed, is creeping up and it has issues cooling. As soon as we get into the upper regions, it's really like go beyond a certain point where the heat from below isn't that large, that huge anymore, then it starts becoming better. I'm curious how our new version is gonna look like with the different print settings now, with some optimizations. Zero retraction gonna give us some stringing, or probably. So let's put the timer. Where do we put the timer this time? Maybe we should remove the door so we can place the phone here. Come on. Where's my timer? Just had it on. This is the time from our last test. Let's delete that. Okay, so I think we're ready. Let's make it a bit brighter. I would say we'll kick it off. Next try. So let's print with the new settings. Let's go. It's gonna take a couple of minutes to warm up again, probably. We have a little bit of a lower bed temperature, hoping for better results for the bottom. And if we can actually be under 15 minutes this time, this would be amazing. Officially it said 14 minutes, 7 seconds. I don't think so much. Maybe it's doable. I would be wondering. What we could also do is, because that's super easy, we can also swap out the nozzle for 0.6 millimeters. I would love to do this just to test out how easy is it actually to switch to another nozzle size and print a benchy with that. Let's see. But let's do this first one now. I think we should fix the focus this time. Okay. How long? How long until we start? Okay, so the hot end is heating up now. Should be almost there. The printer is Iron Man's baby, yeah. We had that last time. I really like those colors. We can actually print a name tag for this printer. We can probably put it just up there. Should we call the printer Iron Man or should we call it differently? Okay, so I'm going to exclude this first line in the front. So really gonna start measuring time as soon as the printer starts printing the benchy. Bottom. Almost there. Should see the homing in a second. My best guess is we also should do some pitch tuning at some point. It is not the best. Temperature honing in is, yeah, it could be faster. Not yet, but almost there. Okay, so here we go. I'm wondering how much faster we can print with these new settings. It feels faster probably because of the retraction that we disabled. I didn't disable decay value. Yeah, you were right. Maybe I should. Do you think this is gonna make a huge difference? The oh yeah, I see the infill is definitely failing a lot. There's a lot of infill problems, but still, let's ignore that for a second. I mean, we accepted that the infill is something that we don't care about. We definitely accept under extrusion for the infill. That's exactly what's happening at the moment. You probably can't see that, but we have to keep it at a distance, otherwise we cannot do the timer. Okay, so maybe we can turn out a few seconds, but let's see. Let's see how much we get now, at least. For me, it looks already quite a bit faster. The lower bed temperature seems also to be helping with the elephant foot, reducing that a bit. Oh, I think we got some. I think we jumped. The printhead was hitting something, and I think we did get a layer shifting just right now. Definitely you can hear that. That's probably due to the missing rejection. So we have a little bit of we have definitely some layer shifting, and I think it's gonna fail at some point. So we should stop it. The thing is, as soon as you get a layer shift, it's essentially over. So why did we get a layer shift? I'm not sure. Probably had some. Not sure if this is the retraction. Some filament oozing, and then we have hitting some part of the print. That's unfortunate. That is unfortunate. Can we somehow fix it? Let's see. We can probably do different things. We can disable pressure advance. We can also reduce the flow ratio just a tiny bit. I don't know. We didn't want, like, the thing is, we don't want, if we enable ZHop, it's gonna be much slower. ZHop costs you a lot of time. I'm not happy about that. It's definitely going to retract. How much does it cost us in terms of time? I did disable the pressure advance. That might also be an issue. Pressure advance might actually make things worse. We can also just risk it and try without retract and disable this infill combination thing. Maybe that is something, yeah. Okay, let's try that. Time's still the same, So that infill combination did not change anything, so for the worse or for the better. Still, I mean, the missing Z-top is definitely, I mean, this is a risk. I mean, if you don't do Z-top and you have anything sticking out from the surface, this can already be game over. But yeah, it's like, don't ask me how many speed benches I did before I was submitting my actual final round. So it's definitely something you have to try stuff over and over. Okay, so let's do it one more time. Let's see if these changes. It's still, infill is still rectilinear. Is there maybe an infill pattern that has less crossing, where the risk of multiple layers crossing is lower? I think direct gyrate, but gyrate isn't gyrate slower? Let's see. I can just try that and see how much that is. Oh, it's much slower. It's a minute slower. I think I was reading that the other day, these different infill patterns. There is a couple of infill patterns where the infill of 2 layers is, for some of these infill patterns, the lines cross and can create a little bit of a bulk. Gyrate, okay, and this adaptive cubic thing. You mean the adaptive cubic? Let's see how much. Is this any better? At least it tells me that the adaptive cubic is the same time as the rectilinear. Adaptive cubic might be better for some details, if it gets dense in detail areas and less dense in the bigger areas where we don't need. But I started the print now with the old settings, so let's keep them as they are for now, and let's see if it comes out any better. So 14 minutes. We can try to push acceleration. We can try multiple things. The thing is, what actually saved us a significant amount of time was the Z-hop and the retraction, and combined was 1 minute. I think did I still disable the retraction now? Yeah. So I've still disabled the retraction now. If we bring back retraction and increase something like acceleration, we could land up with the same time. Just wondering. So let's start all over. This is absolutely possible that the layer skipping or the the skipping that was happening was also due to the motors, the voltage. Maybe we need to tweak the motor voltage a little bit higher, just for the sake of doing the speed benchy. I think some people do this for these shorter prints where they have really a limited amount of time where they want to push the printer higher, so they increase the motor voltages and also the amps, and so that for a short amount of time, I think that's good. You can do that. For longer, I wouldn't do it for longer, but just for the sake of printing a fast Banshee, you can absolutely try that. So, still looking okay, but I see some things happening with the infill. Honestly, there is some plastic that's sticking up. I hope that this is not gonna cause any issues. Wondering if this is caused by the missing retract or the missing Z-top. The problem that you just saw. If it's the same layer, which was gonna happen very soon. Yeah, definitely for this infill section that we just saw, this solid infill section, there was some filament was now sticking up, and it's not very nicely created. It's not very flat. We could hit this with the nozzle, and we could then have a layer shift. I don't know. Maybe this is the reason. This could happen now. Or we were just unlucky. Let's see. This is, I think now at some point it was happening. The extruder is heavily skipping now. I don't know. Maybe you were lucky. Maybe we can overcome this section now and not run into anything, but I'm not sure. There's plastic sticking up. Here we go. We're scratching that. This is critical now. I'm not sure if we can make it. Maybe you can just push over it now and ignore that. At least we're still printing. We don't have a layer shift. Let's hope it stays this way. Is there a rule for the top and bottom layer? Yes, you have to have 3. Are we still good? Yeah, it seems to be still fine. I mean, now I wish that we had the bigger heater element and the better nozzle with the high temperature, the flow rate, the high flow rate nozzle. Because then we would definitely be able to push more filament through, even if we didn't change the speed settings, but we definitely would have, for the infill and stuff, we would have a cleaner outcome. I'm not sure. I would actually increase the printer limits a little bit now and say for one of the next sprints, I would increase the acceleration limits a little bit and just pattern. Rectilinear saving me 20 seconds, yeah. Well, we have rectilinear setting, so we should be good with that. So, sure. I think we made it through the critical part. We definitely can. I think we can assume that since we made it through this huge infill section, the top layer of that Banshee, that we might be now ready for the rest, and we're not gonna skip. Rectilinear pattern for top and bottom surface. Might be. That might be an option. Should we also use this for the internal solid infill pattern? Maybe? Is this going to save us some time? Maybe rectilinear is also going to save some time for the infill. Definitely saving some time, yeah, you could be right. This is around about 20 seconds something. Then there's another setting that I found is apply gap infill. Gap infill is defined as probably that's, where is this defined? Tiny gaps. Should we, maybe if we did the fun part, if we disable tiny gap infill, we almost save another 10 seconds. I don't know. There's probably a couple of potential there yet to save time. Of course, this is all compromises that reduce the overall print result quality, but probably not so noticeable. And I see we definitely get some little bit of stringing now, but yeah, we'll take a look once it's done. It's not terrible, actually. Okay, so still have a couple of minutes to go. Curious if we will really be under 15 minutes now. Ensure vertical thickness. Ensure vertical thickness. Where is this? It's enabled. It's setting to all. What does change if we set this to none? Saving another 20 seconds. Oh my goodness. Okay. I guess we can still chop off a couple of seconds. It feels like, wow. There's still plenty of room there. My goodness. Officially, we're now with this new with the changes, we would be at 13 minutes 22. I'm not sure if this is actually realistic. But let's see. Not bad, yeah. There's not so much stringing going on for no retraction. That's what I was thinking also. Actually, probably we could just keep it off, right? I mean, if this, we'll take a closer look in a second when it's done. This can be removed with no effort by a heat gun. Just by just a couple of seconds, or even maybe just 1 second using the heat gun, it's going to be gone. So why, yeah, we should not probably have it enabled at all. Okay. We're closing the little roof here. It's already done. So let's see, we're already at 13 minutes almost, so where do we end up? Are we gonna stay under 15 minutes? That's the question. Because that was my initial goal for this. We could achieve this. Could be done. I think we're almost there, just printing the chimney. We're closing the roof, finishing the last touches there. So, oh my goodness, we're definitely gonna make it if I'm not wrong. Okay. Chimney. Oh my goodness, we're gonna stay under 15. Okay, 14 minutes, 20 seconds, roundabout. Awesome. Okay, so let's take a look, because I think the stringing was... I was worried about that, but it's definitely not. There's no stringing actually. Just a little bit here in the lower section of that door. But besides that, honestly, there's, yeah, a little bit of stringing here. Nothing serious, honestly. I wouldn't care. I had actually worse stringing going on with prints where we had retraction on other printers, and here we basically have zero stringing. That's completely neglectable if you ask me. And we have a couple of issues here, like this plastic sticking out here from the top. It's just a tiny bit, but so far so good. Elephant foot is... did it really improve? I did reduce the print temperature here for the print bed by 5 degrees. It was sticking still quite well, so I would keep it there. It might be a little bit better. Let's take the other one, the previous one, out. It looks just a tiny bit better, honestly. There's not a huge difference in terms of the elephant foot. But you see the tiny bit amount of stringing here. There is still a little bit of stringing going on in this other print where we had retraction on. So not a huge difference, and also they look very similar, although this one is another minute faster. So yeah, good step in the right direction, I would say. Yeah, the first layer is still rough. This must be a cooling issue, if you ask me. Red is fast. Red filament is faster, do you think? Let's see. I'm gonna do a couple more prints. Not tonight, because tomorrow is Monday and I have to go sleeping, get up early tomorrow. But that has been a ride. This printer build was so much work. I think in the end we achieved actually a great result with this printer build, and for my first Voron I'm actually quite happy how it came out. The colors, the quality, the print speed is definitely really good. Minor improvements maybe that I want to do, but nothing serious, honestly. I would also not invest too much anymore in terms of a better hot end or something. I'd say for the small print volume, this is actually, yeah, it's good enough. And the next build is definitely gonna be coming at some point. Probably we're gonna do something that like pushes faster in terms of pushes more filament through, but not necessarily printing that much more faster in terms of print speed, but really extruding more filament for bigger volume. Let's see when it's gonna happen. A couple of things I have to do in the next couple of weeks. I have to do a couple of reviews for stuff that came in. I still need to catch up. So I'm not gonna jump on a huge project for the next couple of weeks. Probably gonna do some testing of stuff that I still have to test. Another thing that just came in is the Ender 3 V3. So the new Ender 3. So we have to test that. And didn't start the giveaway yet, the new one. We will definitely, I'll set it up as soon as I can. And I will send out the link so you can see what it is. Just probably gonna take a few more pictures of this laser engraving machine for May, and then setting up the new giveaway on the website. Actually, we need to finally close this one officially. Mark as complete. Yes, mark as complete, and it should be complete now. Okay. Great stuff. Thank you all for coming. Thank you for subscribing on Twitch, for following on Twitch, and everyone who was here. And I'll see you next time on Wednesday night. Wednesday night should be should be correct. Wednesday night this week I'm gonna be back. So see you there. Bye bye. Have a good start into